Okay, so we talked about the fact that the Earth revolution around the sun is the origin of 4 seasons, and depending on which part of the Earth you live in, you may get different variation of temperatures. That's what we talked about just a minute ago. So now we'd like to understand why the Earth revolves around the sun at all. So if you don't understand that, you actually haven't really understood where the 4 seasons are coming from. So that will be the next question you might want to ask. And of course, people in the ancient days had different ideas from what we understand today. So people believe that you live at the center of the universe, that's where you are, and everything around you goes around in complete circles. So that used to be sort of the view of ancient people. But the science goes by data, and the reason why we don't think this way anymore is because the observations don't agree with this picture. It's not that we think that ancient people are crazy or anything. It's just that this idea doesn't work. So how do we know that? So what we see in this movie is the motion of Saturn as viewed from the Earth. And you see that Saturn comes in, but sometimes goes back and goes forward and backward and so on. So you see that the Saturn moves in a rather unexpected way. So if you think of this ancient picture that we are at the center of the universe, everything revolves around us in complete circles, you cannot possibly explain this simple observation. Just look at the Saturn every night and you don't understand that. So they had to actually change their understanding on the structure of the universe. So this is the revision to the previous idea. We are still at the center of the universe. Everything is moving about us. But if you look at the Saturn up here, then in addition to this overall revolution around the Earth, it does also its own motion. So as it keeps moving around this way around the sun, around the Earth, it just goes back and forth a little bit in this little cycle called epicycle. So they had added this epicycle on the previous picture so that they could explain the observation. So that was sort of the revised picture of the way the universe should work. But as you can see, this is getting pretty complicated. And as the observation got better and better, even this idea didn't work anymore. So they started putting actually another epicycle on top of an epicycle and so on and so forth, and it got more and more complex. And at some point, people realized that, well, this is just way too complex. The universe should have a simple understanding. This can't possibly be right. And that's when, as you know, Copernicus came in. So he completely changed the idea. We are not at the center of the universe. We are off-centered now. The center of the universe is actually the sun. So he proposed that all the planets move in complete circles around the sun instead of around the Earth. This way, you can easily understand why the Saturn does this go back and forth motion. So if you're looking at the Saturn from the Earth, they go sort of different speed. So as we go on, if the Saturn is sort of falling behind, you might think the Saturn is moving backwards. But if you come back this way, then Saturn is moving forward. So depending on when you look at the Saturn, you might see that it's actually moving backwards or forward. And that's, as you saw in the video, that's what actually Saturn looks like to us. So that seems to be a much simpler explanation on back and forth motion of Saturn. But there was still a problem. If you really look closely at the motion of the planets based on this idea, it looks very simple, but doesn't quite agree with observations either. So there was still a problem people had to solve. And as you know, it was solved only after Kepler. So Kepler pointed out that the orbits of the planets around the sun is not in complete circles. They are an elongated ellipse, not by a lot, but a little bit. And because the data are getting so precise that this little elongation of the orbits in these ellipses instead of complete circles made a difference, and then everything agreed with the observations in the end. So at the end of the day, this simple concept of elliptical orbits explained the motion of every single planet at the end of the day, and that was a very good theory. Namely that whenever we look for explanations behind phenomena, we apply these criteria, what we think is a good physical theory. First of all, if it doesn't agree with observation experiments, the theory is dead. You just throw that away because it doesn't work. So theory has to agree with observations and experiments. But at the same time, we'll be much happier with a theory that applies to many things at the same time. Unified description. We don't want a single theory for Mars, another theory for Jupiter, a different theory for Saturn. We would like to have a single theory of this elliptical orbit that applies to all the planets we can study, and that would be a criteria for a good physical theory. And also, we want the theory to be simple. If you have to put a so-called an epicycle on top of it, yet another epicycle on top of it, and so on and so forth, it's a very complex theory. At some point, you don't think that should be the right theory. We are always looking for a simple explanation to many phenomena we see, so that is one of the criteria for a good physical theory.